welcome back to an episode of Simply Science. All right, everyone. So the first thing I want you to do is locate your static electricity sheet. I'm hoping that you already have it printed out and you put your name and date on the top and you've highlighted the I can statement. So today's I can statement. I can explain what static electricity is, how it works, and why it is different from other kinds of electricity. So basically, what I'd like you to do now is hypothesize. So, I think static electricity is. Remember, your hypothesis does not have to be accurate. It's a scientific guess. What is static electricity? What have you heard about static electricity? Have you ever created static electricity accidentally? Where have you seen it before? Now, the vocabulary we're going to need for this lesson is attract and repel. So attract means that the balloon is attracted to that object. It goes to that object. Maybe it even sticks to that object. Whereas repel is the opposite. Repel means that it will not stick to that object, that it immediately falls off, or that it pushes that object away. So attract, repel. Just like magnets basically attract and repel. It's very similar. All right, everyone. So for this lab, I'm going to need myself, check. I'm going to need some balloons, check. And I'm also going to need paper pieces as well as all of the test objects listed on your paper here. Now, if you have these objects at home, you can actually follow along and do this lab with me. But if you don't have the objects, that's okay. You can watch me do the demonstration of this lab. So what we're going to do is we're going to take the balloon, charge it up on ourselves, and then we're going to test it on those test objects that we have. So on my test object list, which I have in front of me, we have your shirt. So you're gonna charge it up and see, does it stick to your shirt? Paper pieces, tiny, small, cut up or ripped paper pieces are fine. Your hair, the wall, running water, which I'm going to show you a demo of. And then you get to pick two objects. If you're doing this at home, you can pick two objects that are around your house. But if you're following along with me, I'm going to pick a couple objects and then you can record if they attracted or repelled that item. Now you can see that there's actually a second column. Is it a strong or weak reaction? So if it's a strong attract, it's gonna stick. If it's a weak attract, it's gonna stick for a second and then probably fall off. Whereas with a repel, if it's a strong repel, instantly fall off. Or if it's a weak repel, it might kind of stay, but probably fall off anyway. So you can decide the scale of how strong or weak the attraction or repel actually is. Now, one of Miss Rachel's least favorite things in the world, aside from cruelty to animals, is actually balloons. I am not a big fan of balloons.
Nope.
I am so scared of balloons popping.
Nope.
I just don't like balloons. They're not my thing.
Nope.
So I'm going to demonstrate with a special guest, and they can demonstrate on these special objects as well. Mainly so I don't have to touch the balloon. Hi class, welcome back. So many of you didn't know that Mr. Matt is actually my upstairs neighbor. So because I don't like balloons, Mr. Matt's here to help us do some demonstrations. So you can see Mr. Matt is charging the balloon and getting those electrons all fired up, ready to go. So let's try it on some small paper pieces and see if this is attract or repel. Wow, that is a strong attraction. Good work, Mr. Matt. Okay, Mr. Matt, let's try sticking it on those curtains. That looks like a strong attraction to me. What do you think, Mr. Matt?
Yep. Sure does.
I believe I can fly. I believe I can touch.
All right, Mr. Matt, let's try balloon and another balloon.
Here we go.
Ah, interesting. It looks like it doesn't want to be anywhere near the other balloon. That looks like a repel to me. All right, Mr. Matt, let's try your hair. Okay, Mr. Matt, let's try that wall.
All right.
Oh, that also looks like a strong attraction. Great work, Mr. Matt. Okay, Mr. Matt, let's try on our mystery test subject.
Who could this be?
Hi, Mr. Chris. Strong attraction. Okay, everyone. Now that we've experimented on various items throughout the house, we can see which ones had a very strong attraction and which ones repelled. So let's go through now the section on your sheet that says what happened. So I'll read it with the blanks. Maybe we can solve it together. Okay. When you rub the balloon on your shirt, blank, negatively charged part of the atom, build up on the outside of the balloon. So right now you're thinking, okay, what's the negatively charged part of the atom? Oh yes, that's the electron. Great, you got the first blank. When you rub the balloon on your shirt, electrons build up on the outside of the balloon. Next sentence. When the blank charged particles, so we just learned they're electrons, and it says in the sentence before what charge they are, they're negatively charged particles. When the negatively charged balloon comes near objects with a neutral or blank. So remember, opposites attract. So what would be the opposite of a negative charge? It would be a positive charge, right? And that would go in the next blank. So when the balloon comes near objects with a neutral or positive charge, it will be attracted to these objects. Okay, and the last sentence. If the balloon comes near another negatively charged object, so two things that have the same charge, they're going to repel each other. They're going to push away from each other. Remember, opposites attract, likes repel. Static electricity is static, meaning it doesn't move. The fun thing about static electricity, like if you know anything about static electricity, when you kind of charge your feet up on the grass and then you go to zap your friend, or you accidentally zap someone, the reason you only zap once is because that static electricity goes away as soon as it touches something. So you can build up the static, build it up, build it up, build it up. As soon as you release it, it's gone forever. So the difference between static electricity and our normal electricity, which is actually called dynamic electricity, is that static goes away after one touch and dynamic electricity can move. Static electricity can't move. It just, as soon as you touch it to something else, gone. Dynamic electricity, I can put my finger on it and the dynamic will travel through my body and maybe electrocute me. So that last sentence, static electricity is static, meaning it doesn't move. Electricity we use every day to power our devices is dynamic electricity. It can move, it can freely go where it wants through anything that's a conductor, which we'll talk about in a couple more labs. Okay, so to summarize this lesson, guys, basically what we want you to know is that there's a very big difference between static electricity and dynamic electricity. Static electricity you can create with friction on your hair or on your shirt or with your socks on the grass or the turf outside. You can create static electricity, but as soon as it touches something, it will go away because it cannot move through objects. Whereas dynamic electricity can move through objects. It has the freedom to move through any conductor. So that's the main difference between static electricity and dynamic electricity. We also learned the terms attract and repel. Now, I think we've covered these before in previous grades with magnets and other things, but we're reviewing the concept that attract means to be attracted to one another, to stick together, to come closer together, and repel means to push away from each other. They're not attracted, they're doing the opposite. So attract, repel. That is the basic premise. Okay, this lesson also required us to review our knowledge of the parts of an atom, which we know are the proton, the neutron, and the electron. And we're reviewing the fact that protons are positively charged, electrons are negatively charged, and neutrons are neutrally charged, which means they don't have a charge. Remember, electrons are the ones responsible for creating electricity, the negatively charged particles. Okay, everyone, so there are 3 questions at the bottom of your page. I'm going to read through them, but I'm not going to give you the answers because I think I'm going to give you these as homework questions on Edmodo today. So look out for these questions as short answers. They'll probably go up around 8 or 9 a.m. once you're done this lesson, hopefully, but you have all day to finish them. Just remember, once you start a quiz, you only have 60 minutes to complete it, which is more than enough time. You just have to make sure you're focused and not grabbing a snack as soon as you hit start. Number 1, which test items had a neutral or positive charge? Now, anything with a neutral or positive charge would have been attracted to the balloon because the balloon is full of electrons. So anything that attracted to the balloon should go under number 1. Number 2, did any test items have a negative charge? So was there any items that the balloon wasn't attracted to? What were they? Okay, number 3, do you think static electricity can be useful or just annoying? Now this is completely an opinion question. Static electricity, for the most part, we've all experienced as a quick, annoying, zzz, oh my gosh, where did that come from? But do you think there's any possible uses for it? Give me some ideas, or just tell me, no, think it's just annoying and I can't think of any possible uses for it. All right, everyone, great work today. Don't forget to add any words that you learned today or new glossary terms into your glossary in your binder, which you should all have. And thank you for joining me on another episode of Simply Science.